My name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 275. Day before yesterday, we began solving data sufficiency problems. This book that I just showed you, 13th edition, the official guide, contains 230 problem solving questions, 174 data sufficiency questions. We have already solved all of these problems from this book. You will find the solutions from day 1 to day 250. Right now we are redoing the problem at a little bit of, all these problems at a little bit of a faster pace. Day before yesterday we began solving data sufficiency problems, and we're going to continue our work here. Problem number 10 is what we are about to solve. In problem 10 we are told Pat saved $600 of his income last month. Question is, how much did he earn? We are told that he saved $600 last month of his income. Question is, what was his income? What was his earning? Let's see what they tell us. In statement 1 they tell us, first of all, AD, BCE. And if you still do not know what I'm doing here when I put down AD, BCE, as I remind you in every video, it is important, it is imperative, it is crucial, it is vital, it is essential that you watch this video. Just type in data sufficiency and the word intro along with my name and watch that video. You will get something out of it. This will make more sense to you what I'm doing here. In the first statement we are told that he spent half of his income. And we are also told that he saved 1/3 of the remainder. It's very important that we pay attention to the words. We are not told that he saved 1/3 of his income. We are told that he saved 1/3 of the remainder. The question is this information enough? Is this sufficient data? Does the first statement provide us sufficient data to be able to answer the question? The question is, how much did he earn? Let's find out, shall we? He saved 1/3 of the remainder. Remember, he spent half, so he must have saved half. He must have saved 1/3 of the remainder. 1/3 of the remainder, which is half of his income, because he spent half of this, which means the remaining half is there. 1/3 of the remainder, which means he must have saved 1/6. He saved 1/6 of his income. We are told, so now we know that 1/6 of his income. Now we know that 1/6 of his income must be $600, because we are told that he saved $600. That's it. We are done. 1/6 of his income must be $600. We don't have to waste our time to finish it, but it only takes a second. But you can clearly see it's enough information to figure out what the income is. The income is 6 times the amount. Income is $3,600. The first statement by itself is quite sufficient. Which means the answers cannot be B, C, or E. It will have to be either A or D. Let's look at second statement. That's it. We're done with this one. Let's look at second statement. In the second statement, they tell us that he paid twice as much. In taxes as he saved. He paid twice as much in taxes as he saved. We know he saved $600. So what the second statement tells us, the only thing that the second statement tells us is that he must have paid the amount of taxes that he paid. He must have paid twice as much, which means he must have paid 2 times 600. 2 times 600. He must have paid $1,200 in taxes. But what does it have to do with how much he earned? We want to find out how much we earned. So at this point, what the second statement tells us, what the second information that the second statement provides us is that he paid $1,200 in taxes. We also know that he saved $600. But these two bits of information obviously is not going to enable us to figure out what his total income was. Second statement is not sufficient. Second statement by itself is not sufficient. The answer is not D, the answer is A. Second statement is not sufficient. Let's move on. Number 11. Number 11. In number 11 we are given a triangle here, and we are number 11 here. It says, is triangle PQR of a right angle triangle? That's the question. The first statement tells us triangle PQR is a right angle triangle. The first statement tells us that the points P and Q have the same x coordinate. Points P and Q have the same x coordinates. In other words, here's our point P. If the point P has the coordinates of x1, y1, let's say, then point Q also has the same x coordinate, which is x1, and of course this one is going to be y2. What this tells, if these two have the same x coordinates, if these 2 points have the same x coordinate, what that tells us is that this line here, line PQ, this implies that the line PQ is parallel to y-axis. Well, it's parallel to y-axis, but that does not in itself enable us to answer this question. Is that a right angle triangle? It could be a right angle triangle. It could be a right angle triangle, or it could be something, or it could be something else. It could be the angle might be something like this, or angle might be something like that. Without knowing anything at all about the bottom line, we need to also know if that line is parallel to x-axis or not. We know now that this line is parallel to y-axis, P to Q is parallel to y-axis, but somehow we have to figure out if this line P to R is parallel to x-axis or not. That information is not provided in the first statement. First statement by itself is no good. The first statement by itself is no good. A, D, B, C, E. Since the first statement by itself is not sufficient, we know the answer cannot be A or D. Let's look at second statement. In the second statement they tell us that points P and R have same y coordinates. Well, there we go. They have the same y coordinates. Now we are talking. So here's our point P. It had point P, we said it had coordinates of x1, y1, and here's our point R. And we are told that they have the same y coordinates of this. So if this is y1, this one would have to be y1, and the x coordinate would be something different, x to y1. There you go. So this tells us that the line PR is parallel. This tells us that the line PR is parallel to x-axis. There you go. Again, this statement by itself actually doesn't do anything. This statement by itself actually does not tell us if the triangle that we're looking at is right angle or not. It could be right angle or it could be something like this. So this by itself doesn't do anything. So answer is not B. Let's put the two statements together, and when we put them together, of course, it's a very clear-cut situation now. It's a very clear-cut situation because the first statement tells us this part, that the line P to R is parallel to x-axis or y-axis, and the second statement tells us, this comes from the second statement, that line PR is parallel to x-axis. Well, if this is parallel to x-axis, if line PR is parallel to x-axis and the line PQ is parallel to y-axis, then it stands to reason that the angle that they formed would have to be 90 degrees. Of course, this is a bit redundant because this symbol in itself means 90 degrees. Anyway, the point is, if you put the two statements together, it does the job quite nicely. We need two of the statements together, the answer is C. Each statement by itself is not sufficient, but when you put them together, we do have sufficient data to be able to answer the question. The question was, is this a right angle triangle? The answer turns out that it is a right angle triangle because this is parallel to y-axis and this PR is parallel to x-axis. Let's move on. Number 12. Number 12, we are told that the water is being pumped into a well, or rather in a tank. One does not pump the water in the well. And there's a limit to insanity, you understand? And water is being pumped out of a tank. So there is an inflow and there is an outflow, they're telling us. Then the question simply is, how fast is the water level rising? How fast is the water level rising? Well, as you can clearly see, in order for us to be able to figure out how fast the water level is rising, the logic dictates that we need to know the rate of inflow and the rate of outflow. In other words, we need to know the net inflow. Of course, the rate of inflow would have to be more than the rate of outflow, obviously. We need to know the rate of, we need to know the net inflow. Let's see what the first statement tells us. The first statement tells us that the initial level is 200 gallons. Now, does that do anything? Does that provide us any useful information? The point here is not that the first statement is not sufficient. The point here is not that the information that is given in the first statement is not sufficient. The point here is that this is not that it is not sufficient. It is worthless. This information is worthless. Knowing the initial level of the water, and when the story began, is not going to enable us to figure out how fast the water level is rising. How fast the water level is rising is completely independent of how much water there was in the tank to begin with. It has nothing to do with it. A, D, B, C, E. A, D, B, C, E. First statement. Ordinarily, we said that the first statement is not sufficient. Here, the first statement is actually worthless, and I'll show you in a second why this word is important. But anyway, even if the first statement were not sufficient, even if it were not worthless but simply not sufficient, the answer we know cannot be A or D. But the fact that we just ascertained that it is worthless, this word, knowing that it is worthless, also tells us that the answer cannot be C. Answer cannot be C because C tells us that if you put the information from the two statements together, then you can do the job. Well, once we look at the second statement, and if it turns out that the second statement, listen very carefully, once we look at the second statement, if it turns out that the second statement by itself is not sufficient, then trying to put the two statements together will be a sheer waste of time. What's the point of putting this information from the first statement? This information that we already agreed is worthless. So this information is not going to add anything to our knowledge once we combine it with the second statement. If it turns out the second statement is not enough, then the answer will simply be E. Answer is going to be either B, which means the second statement by itself will turn out to be enough by itself, and if it doesn't, immediately we will know that the answer is E. We won't bother putting them together. That will be a sheer waste of time. It's worthless. This information that they're giving us, the initial water level, is actually superfluous, gratuitous, unneeded, unwanted, unrequired, uncalled for. Do you understand? It is completely unnecessary. In case you're curious, and in case you're interested in improving your vocabulary, the word was gratuitous, which means unneeded, unwanted, unrequired, uncalled for, unnecessary. We learned this word in our vocabulary lesson on day 47. If you're interested in improving your vocabulary, you can watch the vocabulary videos. On day 47, we learned this word, gratuitous. Let's move on then. Enough of the talk. Let's look at second statement. Oh, I shouldn't have erased that part. A, D, B, C, E. A and D cannot be the answer. C cannot be the answer. Let's look at second statement. Second statement tells us that the rate of inflow is 10 gallons per minute. It tells us that the rate of outflow is 10 gallons per 2.5 minutes. Well, there you go. We know the rate of inflow, we know the rate of outflow. We're not going to actually waste our time trying to figure out the net inflow. The question is, how fast is the water level rising? We're not going to actually waste our time to figure out how fast it's actually rising. That's not the point here. These are called data sufficiency. And this is the sufficient data. Second statement does provide us sufficient data for us to be able to answer the question, how fast is it rising? The answer is B. Now what we're about to do is something, as I already said, we're not going to do in the real exam, but we're just going to take a second just for the hell of it. You understand? Just for exercise. 10 gallons per minute. This is 10 gallons per 2.5 minutes. So if you multiply this by 2.5, if you multiply this by 2.5, what we find out is 10 times 2.5 is 25 gallons per 2.5 minutes. The rate of inflow is 25 gallons per 2.5 minutes. The rate of outflow is 10 gallons per 2.5 minutes. The rate of net inflow, the net inflow, it turns out is 15 gallons per 2.5 minutes. And if you're interested to figure out per minute, you just divide both by 2.5 and you're done. But we're not going to do all of that. It's not necessary, you understand? Let's move on to number 13. Just give me 1 second. Number 13. Is x a negative number? Is x a negative number? What the hell? Is x a negative number? That was number 13. Oh, we are on the next page now, aren't we? We are on page number 276 now. Is x a negative number? As you can see, that's all they're asking here. Is x a negative number? Pretty straightforward, pretty simple question. And of course, questions are always straightforward and simple. It is the answer that gets prickly, doesn't it? Let's find out, shall we? Do we have enough information to be able to answer the question? Question is x a negative number? That's all. Very simple, very straightforward question. The statement 1 tells us that 9 times x is more than 10 times x. Well, if 9 times a number is more than 10 times a number, then that number must be negative, because you see, 9 times 3, of course, it's not going to be 10, it's not going to be more than 10 times 3. But 9 times negative 3 is going to be more than 10 times negative 3. That tells us that the fact that 9 times the number is more than 10 times the number, that tells us that x must be negative. X would have to be negative. There is no other choice. X would have to be negative. The first statement by itself does the job quite nicely. First statement by itself is enough. A, D, B, C, E. A, D, B, C, E. I didn't mean to say it like that. A. Let's do it one more time. A, D, B, C, E. That's how we say it. A, D, B, C, E. The first statement by itself is enough, which means the answers cannot be B, C, or E. It would have to be either A or D. If it turns out that the second statement by itself is also sufficient, then in that case the answer would be D. If it turns out that the second statement does not provide us enough information to be able to answer the question, is x negative, then in that situation, then in that case, the answer would remain A. Let's look at second statement. In the second statement, they tell us that x plus 3 is positive. Second statement tells us that x plus 3 is positive. Is that enough to be able to answer the question whether x is negative? For sure. Well, find out. If x plus 3 is positive, well, we can have two situations. We can have either x could be x plus 3 here, here's x plus 3. X could be positive 1 plus a 3, and that's positive. As you can see, this is positive. Or x could be negative 1 plus a 3, and that is also positive. As you can see, in both of these scenarios, x plus 3 is positive quantity. X plus 3 is a positive quantity here when x is negative 1, and x plus 3 turns out to be positive quantity when x is a positive 1. And since we do not know which one it is, it turns out this statement is not enough. We could have done it with 1, we could have done it with 2. X could also be, of course there are infinite possibilities. Nowhere in the problem it tells us that x has to be an integer. I'm just doing integers to keep our life simple. But x could be negative 2, or x could be positive 2. Negative 2 and a positive 3 is again more than 0, and so is this one. So again, x could be positive 2 or negative 2, x could be positive 1 or negative 1, and of course infinite other possibilities. The second statement by itself does not do the job. The answer is A. The second statement by itself does not do the job. Let's move on then. Number 14. Number 14, just give me 1 second. Let's see what number 14 says. I and j are integers. It doesn't say they are positive integers, you understand? It all it says is that I and j are integers. And the question is I plus j even? Is this quantity even, they are asking. Let's see what they tell us in the first statement. The first statement tells us that I is less than 10. Simply knowing that I is less than 10, actually, it's not that it is not enough, it is not that this information is not sufficient, it is a worthless information. Knowing that I is less than 10, that tells us nothing at all about whether or not the sum of the two quantities is even. The first statement does not do the job. A, D, B, C, E. Answer cannot be A or D. The fact that we claim that it is worthless, that tells us that putting the two together will not get us anywhere. Answer cannot be C. Let's look at second statement. The second statement tells us that I equals D. Well, there you go. If I equals G, then that tells us that I plus J equals to 2 times I or 2 times J. And now 2 times I, 2 is an even number. It doesn't matter whether I is even or odd. Even times odd is even, and even times even is even. So it doesn't matter whether I turns out to be odd or even, but it doesn't matter whether I turns out to be odd or even. The fact that I equals j, which means I plus j is 2 times I, and 2 is even. So even times even is even, and even times odd is even, which means this quantity, 2 times I, is always going to be even. In other words, I plus j is always going to be even. Question is this quantity even? The answer is yes. Similarly, we could have made an argument with j. 2 times j has to be even because 2 is even, and 2 times j is going to be even. It doesn't matter whether j is even or odd. Do you understand? The second statement by itself does the job beautifully. The answer is B. The answer is B. That was it, I guess. I'm going to stop right now. This is what we're going to do today. Okay? I'll see you tomorrow. As I said before, each day we're going to do a few problems and we're going to keep making our progress. The goal, of course, is to go to the very end, just like we did in round 1. This is round 2. We already, as I explained to you already, we've already solved all of these problems at a slower pace. But just like the first time around, our goal is to go all the way up to 174 and all the way up to 230 for problem solving questions. Few questions every day, little by little every day. Do you understand? I'll see you tomorrow, okay? Bye now.